Hey guys, so let's go ahead and get going on what we're going to be looking at today. So, when we're looking at today's lesson, guys, we're going to be going back to something we've talked a little bit about before, a median. If you remember, median is talking about what the data point that lies in the middle of a set of data. And what I want to do is kind of look at a lesson here, guys, that is going to give us an idea of median in what you would call real world situations, like basically situations where it's realistic. You're not just given a set of numbers, you're given a situation that is a very reasonable situation that could happen, and saying, oh, well, yeah, median would be a fairly useful idea to look at in this situation. So we're going to look at two ideas, guys. Um, and one kind of gets more into finding the median than the other one does, but they're both really good examples of scenarios that maybe you might not think of for one of them, and the other one probably more expected since we've talked a little about this scenario before. But let's go ahead and just get right into it. So, guys, the notes we'll be using again will be on the assignment page. Just look up to the one for today's date. It will be 4/13/2020 notes. And I've already filled this one out for the most part. I'm just going to add a couple things to it that I kind of considered upon looking at it another time. But the paper we're looking at is the one that says lesson 12. It says describing the center of a distribution using the median. So that's the sheet we're looking at. And we're just going to kind of read through this scenario that they give us here and answer a few questions on it. I think that today's lesson is going to be shorter lesson. It'll be a shorter one than we've done the last couple days. But I still think some good ideas to consider as we go through this. So let's go ahead and jump right in. I'm just going to read through it just a little bit to give us an idea of what's going on, and then we will talk about what we're going to be looking at. How do we summarize a data distribution? What provides us with a good description of the data? The following exercises help us to understand how a numerical summary provides an answer to these questions. Okay. On example 1, they call it the median, a typical number. Suppose a chain restaurant, which they call restaurant A, advertises that a typical number of French fries in a large bag is 82. So in other words, what you would typically expect it to be is 82 fries. The dot plot shows the number of French fries in a sample of 20 large bags from restaurant A. Okay, so they give you the dot plot. It says number of French fries in a large bag, restaurant A. There's the dot plot. They give you just the distribution of it. It looks from how they drawn it. But we're not too worried about variability right now. We're just kind of looking at what they've given us so far. So right below that dot plot, it says, sometimes it is useful to know what point separates a data distribution into two equal parts, where one part represents the upper half of the data values and the other part represents the lower half of the data values. This point is called the median. Shouldn't be any surprise there. Again, this isn't exactly an entirely new idea we're looking at today, guys. We're going to expect to know some of this information already simply because we've practiced median before. So shouldn't be. If you are trying to find the point in the exact middle of a data set, it would make sense that if you're right in the middle, you have an equal amount on either side of you. It's kind of like if you're drawing a diagram that represents a half. So I could just kind of quickly draw one like that just to kind of get what they're saying here. And again, I'm no artist here, just drawing the diagram. So like for instance, here's a diagram right here. This represents like 1/2. If I filled in one of them, it'd be 1/2. Well, you could kind of consider this to be what you would call the middle, the median. No, I mean not exactly, but you gotta get the idea. Here's the middle of the diagram, and clearly half of it is on one side and half of it's on the other side. That's kind of what they're getting at when they're talking about median. Again, it's not really median they're showing you on the picture I showed you, just kind of showing you what they're talking about when they're saying half is on one side and half's on the other. Okay. So guys, here's an idea. They're asking a few questions here, guys, and we're going to go ahead and look at exercise 1 through 3 and talk about a few ideas. And here's the part where I'm going to add a little bit extra, but don't worry about that just yet. On number 1, it says you just bought a large bag of fries from the restaurant. So you are aware of this distribution that we just looked at, that dot plot, and you buy a bag of fries from there. And it says, do you think you have exactly 82 French fries? Why or why not? So they are most likely, when they said a typical bag of fries is 82, like I said earlier in the problem, when we were first reading it, they are most likely talking about the median there. They're saying, okay, the median for the fries is about 82. So they're asking you, okay, if you were told that to expect 82, and we're assuming they're saying that the median is 82 in this situation, since the median is 82, does that mean you should expect to get 82 based on the dot plot that we're looking at here? We'll take a look at the dot plot for a second, and based on that dot plot, keeping in mind that each dot is representing someone buying a bag of fries, and that's how many they got in their bag. If that's the case, would you expect, if you bought a bag, to have exactly 82 fries simply by being told that the median's 82 as well? Well, couple reasons I would say no. So they're just asking, if you had a bag, will you get 82? The first idea I had was this. I mentioned probably not, because they most likely are not going to count 82 fries every time. So that's what I said on the first part, and I went ahead and labeled it with a number 1. But I mean, think about that. So just because they're saying, oh yeah, the median's 82, that doesn't mean they're sitting there and saying, okay, guys, every time you give out a set or a large fry, make sure you count out 82 fries exactly. Because think about that. That would not be very practical. And we've been in fast food restaurants before. We've been in places like McDonald's, Wendy's, stuff like that, most likely. And if you've ever paid attention, which, you know, I'm sure we've been in there enough times to see it, but when they get fries for you, they just quickly, they're trying to go as quick as they can, right? They got to get to the next customer. They're trying to make as much money for their business as possible. And also, they know that you want your food quickly, hence why they're calling it fast food. They don't want you taking forever to get their food for you, because they need 82 fries. They don't sit there and pull out one fry at a time and count all the way up to 82. That would take forever, especially if you're trying to run a fast food restaurant. There's no way that the customers are going to be very happy if someone's sitting there counting out that many fries. Now, they may appreciate getting as many fries as advertised, but at the same time, they're probably not too worried if you're a few fries off. As long as their container of fries looks pretty full, they're not really going to care if there's 82 fries. Because if you've been in the restaurant, as I was getting at, they're just scooping up fries, filling it in. Okay, that looks full, and tossing it in the bag and moving on. So just because the median is 82 doesn't mean it's probably all that likely you're going to get exactly 82. Because remember, median is just kind of a way to describe the center of it. And if it's in the center, that doesn't mean that everything's 82. That just means the center of the data is 82. You could land over on the larger side or the smaller side of that data. So you can't just trust the median to tell you exactly what you're going to get. Now, here's another idea I had on that, hence why what I just wrote, I went ahead and put a number 1 there. I'm going to put a number 2. I'm going to write it up here just for sake of room. But here's a thought too. Look at the dot plot. they're asking, should you expect 82 fries? Well, if I take a look at this dot plot really carefully, trying to get it all on there. If you find 82, 82 is in between 80 and 85. So if I look for 82, 82, if I can find my finger here, 82 should be somewhere about right there, right? Something about there. Well, if you look above it, there are no dots up there. In other words, so far, just because the median's 82 doesn't mean anyone's gotten it yet. So apparently at this point, no one has gotten 82 fries. Well, if that's the case, if no one's gotten it yet, does that help your confidence that you're going to get 82 fries if it hasn't happened yet? Probably not. Now, does that mean it can't happen? No, it could definitely happen. But if it hasn't happened yet, you probably wouldn't have your hopes up that it's going to happen on the exact time that you do it. Like all of a sudden, you're going to be the lucky one that gets that 82. Probably not the case, simply because it doesn't seem to be, it's not, according to the dot plot, a very likely occurrence since it hasn't happened at all. So right above that problem on number one, I'm going to add in a second idea on number two. I'm going to add that also no, because nobody has gotten 82 yet, according to the dot plot. Okay, so, and a lot of times it's kind of like I'll believe it when I see it. If it hasn't happened yet, you're not going to be too confident. So, sorry if it's a little tough to read on that. That pen's not the greatest there. But I added a number two up there. No, because nobody has gotten 82 fries yet. According, again, sorry, my pen's not the greatest right now. According to the dot plot. So there's my answer there. So there's that first question. All right. And feel free to pause if you need to catch up on that. And again, my apologies for the handwriting there. And then they ask another idea. So before we get to that, though, let's just think about what we just said. So did the median, while the median is a piece of data to consider on this problem, did it give us a whole lot of confidence in the situation to predict yet? I would say no. Now, at the same time, you could consider it like this. The median would probably at least maybe give you an idea of where to kind of guess what you might get. You might, and honestly, if you said 82, you might get close to that because the median describes the center of it. You're not, according to this, maybe you'll get 82 exactly. You might be the first one to get it, but probably not. But at least the median might help you have a close guess of how many fries you're going to get on this. So that could be at least something helpful about the median in this situation. It could just kind of be a helpful estimator for you. So they ask another question here on number two. It simply says how many bags are in the sample. Remember, the sample is just how many numbers did you collect or how many responses did you collect. Like in this case, the number of bags are represented by the number of dots on the dot plot. So, for instance, just kind of get to the point here, and I'll get to another example in a second. If I want to know how many bags there are, I just count all the dots on this dot plot. So all you have to do is sit there and count them. And if I were to count them just real quick, I see 2 here, 2 more there, and 2 more. That's 6. I see 4 right here makes 10. 2 more makes 12. 2 more again makes 14, 15, 16, 17, 18, 19, 20. So I see 20 dots in that dot plot. And again, just kind of explained it down here on number 2. So it's, let me fold it here real quick, guys. Sorry about that. Just want to make sure it's a little easier for you guys to see. I know there's a lot written on that paper, so I don't want you to get lost there. So how many bags were there? 20. I just said count the dots on the dot plot. So that's what we have so far about this. Okay. So if we look at the second part of the notes, it asks a question. And here's more of an application idea too. This will take a little bit more critical thinking on it. I think a good tester at least. And I think it wouldn't be a bad idea, guys, when I ask this question, just kind of pause the video, take a second, see if you can figure out the ones. And I'll even give you a hint when I give you a little time to think about it, about how many answers to expect. Just kind of give you a little guidance there. It says on number 3, and again, on the second sheet of the notes, we're on the back side. I will show you which one I'm talking about, but I'd be giving away the answer since they're already circled. But I'll just read it to you. It's on number 3. It says, which of the following statements or statements, could be more than one, would seem to be true for the given data? Circle the ones that you think would seem to be true. If you think it's true, circle it and then write down why. So there are 3 choices. They are half the bags had more than 82 fries in them, half the bags had fewer than, and if you got a random bag of fries, you could get as many as 93 fries. Actually, now that I think about it a little more, if you're going to pause the video and try to figure out the ones that are correct, I'm just going to say this. There's more than one that's correct, but I'm not going to tell you how many. But I will say there are at least 2 that are correct on this one. So if you want to pause the video and try to figure out which ones are the ones that are likely to be true or just simply are true, you can go ahead and pause and try to figure out the 3 if you have the notes in front of you. And if not, I'm just going to go ahead and get straight to it, just to kind of keep it moving here. So let's just talk about our options. So that's what's helping guide me to figure out whether these are true or not. So keep that in mind. So the first choice says half of the bags had more than 82 fries in them. Well, keep in mind, here's our dot plot, and they're saying half of those bags, and every dot is a bag, right? Half of the bags have more than 82 fries in them. Well, think about what we said on the previous question when they asked how many bags are there. There were 20 bags. So if we're talking about half of those, what's half of 20? Half of 20 is 10. So if we are to prove that half of those bags have more than 82 fries in them, we're going to have to look at that dot plot and see if half of those dots are more than 82. In other words, are 10 of those dots more than 82? Well, let's just pull up the dot plot and take a look. So I'm just going to fold it again here just to make it a little easier to follow. Here's my dot plot. 82 is about right here. And if I want to get bigger, I got to go to the right. Well, let's see if there's 10 that are bigger than 82. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, there's 10 dots that are more than 82. So are half of the bags, do half of the bags have more than 82 fries in them? Yes, they do. So I circled the letter A, and I just wrote right beside it that 10 bags did. Simple explanation. In other words, 10 bags had 82 fries. You could say it like that if you want. And I'll put all this up on the screen here in just a second. But I don't want to give away more answers, so I'm not going to put it on the screen just yet. So the next part says half of the bags had fewer than 82 fries in them. Okay. Well, a lot of times when you're given a multiple choice question like this, sometimes it can be easy to say, okay, well, if one option is true and they give you the exact opposite one, then that one can't be true. But let's think about this one a little closer. So before you totally give up on B, it says half of the bags had fewer than 82 fries in them. Almost an exact same approach to the first one on A, but the only difference here is that this one says fewer than 82 fries. So we still have the same idea here. We want half, and half we decided was worth 10. But this time we want to see if there are 10 that are fewer than 82. And if there are, then B is also going to be true. Well, I'm going to pull up the dot plot again. So here's the dot plot. And like we said, 82 is about right here. And if we want to be fewer than 82, we have to go to the left. Left is less. And I'm going to see if I got 10 that are fewer than 82. Well, I got 3 here, a fourth one. 2 more makes 6, 7, 8, 9, and 10. Well, there's the 10 we were looking for. So 10 makes half, and those are all fewer than 82. So are half of the bags fewer than 82? Yes, they are. So again, I'm going to put the same explanation too, because honestly, it's the same approach, right? If you can prove that 10 are fewer than 82, then it's a true statement. So I'll go ahead and put it up here, try to keep y'all from seeing. So on A and B, well, sorry about that, guys. I'm not totally perfect at doing this folding stuff. Let me fix that real quick. Might give away an answer here, but honestly, that's okay. Okay. That's a little bit better. There we go. Didn't give anything away either. So I circled A and B. They are true because 10 bags did have that amount. Or 10, you could say 10 bags had more than 82 on A. And then on B, you can say 10 bags had less than 82. Or sorry, fewer than 82. Doesn't really matter how you word it. So that's just all I did to explain that one. So let's go ahead and look at the last 3. So we've already proven at least 2 of them are right. Let's see if any more of them are right. Well, think about C and D. If you figured out A and B, you don't really have to do a whole lot to figure out C and D because it's just a matter of carefully reading what the question says, or the statement, really. If you know that half of the bags have more than 82, and think about that, exactly half of them had more than 82. That's what we figured out. Well, C says more than half of the bags had more than 82 fries in them. Well, if exactly if exactly half of the bags have 82 fries in them, is it possible for more than half to have more than 82 fries in them? No, not at all. You can't have exactly half and then have more than half in the same scenario. So I would say C has to be false. You could also look at your dot plot again and remember that you only picked 10 out of 20 bags to have more than 82 fries in them. Is 10 out of 20 more than half? No, it's exactly half. So even there, if you didn't follow the first explanation, the dot plot would still help you determine that C is not correct. So you don't have to do anything on C, guys. It's just leave it blank and move on because it's not correct. Same idea on D, guys. D also says something similar to B, but in this case, it says instead of exactly half of the bags having fewer than 82 fries in it, it says do more than half of the bags have fewer than 82 fries in them. Same idea. You can't have exactly half and more than half in the same exact situation. So D cannot be right. And once again, if you look to the dot plot, there are exactly 10 bags that have fewer than 82 fries in them. 10 out of 20 is not more than a half. So D is also false. So you just leave D blank as well. So C and D both are false. Okay, let's check E. We're either going to have 2 correct or 3. 3 fries. Okay. We just got to read that one carefully. They're saying someone just is in a hurry and they just grab a bag of fries and hand it to you out the drive-through window, and there's your random bag. They didn't look carefully and say, okay, let me find the one that has exactly 93 and give it to them. Nope, they just picked a random bag and handed it to you. So there's your scenario. You have a random bag of fries, and it says you could get, keyword could, you could get as many as 93 fries. So they didn't say you will get 93 fries. They're saying you could get 93, right? So the question is it a possibility to have as many as 93 fries? Well, if all we have to work with is that dot plot, let's just see if the dot plot sees 93 as a possibility. And then if it is, well, we can run with that. So if I pull up that dot plot one last time, I'm going to see how big they get. So I'm just worried. Here's the dot plot. I'm going to focus on the larger numbers real quick. Well, if I look at the larger numbers here, guys, there's 85. Here's 90. Okay, here's 90. That means this has to be 91. And then this first dot's 92. And the second dot has to be a 93. And just to prove myself, that's 94. That's 95. It seems pretty clear that each line's worth 1 on this dot plot. So since there is a dot at 93 right here, is it possible to have as many as 93 fries? I personally would say yes, because think of it like this. 1, it was on the dot plot, so it's happened. And 2, if something happens once, most of the time, can it happen again? Yeah, a lot of times it can. Does it guarantee that it's going to happen again? No. But at least it's in the realm of possibility, right? So I went ahead and said it's true. And I simply finished off the problem by my explanation was it has for that one. So we got one more problem, guys, that we're going to look at here. It's going to be a simple one, guys. We'll talk about a little bit of an extra detail here too. And then I'll go ahead and just kind of get y'all going on the assignment. I think it'll be a nice, easy assignment to start the week. We'll get to that in just a second. Let's finish off this last problem, A, B, and C, and then we'll talk about the assignment. And again, guys, if you have questions on the notes or anything, I'll be happy to help you out. Last week or so, y'all been asking some pretty good questions, and it feels like we've been able to answer most of y'all's concerns or confusion. Keep them coming, guys, and I'll do the best I can to help clarify any kind of confusion you have. To just keep that in mind. You can always ask me something, and I will give you the best explanation I can give you or lead you to the most helpful place I can to help you find the answer to it. Okay. So the last one is example 2. It says, examine the dot plot below. Again, guys, like I told you, one of these examples is a scenario that shouldn't surprise you because we've talked about it before. Because the dot plot is talking about grades on a science test. Well, we've talked about that. Statistics are very useful when you're grading stuff because you can figure out what's the average. Is a student above or below the average? What happened the most often? What was the middle score of a test? It's different stuff like that. It's good to see where does each student line up. So if I can see, okay, on the last 2 tests, John has been below the average. Maybe we should have a conversation and talk about how can we make for a more successful time in the class for him and help his grades get a little better or, get it to where he'd like them to be. So again, there's a pretty good useful scenario of when that could be useful. So they give you a dot plot down here, right in the middle. Again, don't want to give it too much stuff away. So let's show you it again. Here's my dot plot. Or as low as a 55. Now, to their credit, there aren't a lot of really, if you look at all the dots on this diagram, guys, there's not a lot of really bad scores or bad scores in general. There's one F, looks like 3 that are under a 70. All the rest of them appear to be above. So it's not the worst test results ever, but again, the scores are ranging from a 55 all the way to 100 here. And honestly, guys, my theory about it is if we have a lot of people making really high scores like these people did over here, we definitely want to talk to the ones that aren't doing that well on it, because it's clearly being shown that it's not an impossible test. It's not impossible to get an A. If we think of A as a 90, and just let me double check and make sure I'm not looking at that wrong. Yeah. So I see a 9, 1, 2, 3, 4, 5, 6, 7. There's 8 people that apparently made an A, according if I read that right. Yeah, it looks like there's 8 people that made an A on it. So clearly it's not an impossible test. So we'd probably want to be talking to those kids that didn't do as well on it, just to kind of help them out and see what we can do to help the next assessment be more successful for them again. So just a thought there, but not something we're really going to be too concerned about. Let's just go ahead and get straight to the idea here. Just kind of giving y'all a little bit of perspective of what I would be thinking if I graded these tests and was looking at my results with that dot plot in front of me. So it says how many data values are represented in the dot plot above. Well, we have answered a question like this on actually the other side of the sheet when they were asking how many bags of fries are there, because it's the same idea. To get the number of bags of fries, you counted the dots on the dot plot. Well, if you want the data values, every data value on a dot plot is just each dot. Each dot is a data value. So all you have to do on it is look at your dot plot and count it up and see what you get. So if I pull up my dot plot, just take a quick look. I'm just going to count up my data points, see where I'm at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I see a total of 28 dots on that dot plot, which means that I have a total of 28 data values on the dot plot. So again, just trying not to reveal extra information here, guys, but to answer A, it's simply 28. That's all you can say, the number 28, right? So again, guys, these questions on this problem aren't too bad. They're fairly straightforward, mostly because this is a pretty simple median question based on what we already know about it, guys. Really, guys, I don't expect any of us to be having much issue with this problem, simply because this is meant to be more of an introduction to median. But I thought it was a good kind of way to go back to it to see where we're at with median, and also see where median fits in the real world. So B says how many data values should be located above the median, and how many should be, above the median, and how many should be below the median. Well, if you have 28 and the median is supposed to split it in half, well, one thing you could think about is if I were trying to split 28 in half, what would each half get? And that could be as simple as just taking that 28 and dividing by 2, right? And that should split it in half. Oops, let's make sure we're on the right one here. 28 divided by 2 gave me 14. That means if I took that list, the median is telling you the middle value. So that's what I had on B. I think that should be pretty self-explanatory, guys. If we know that median is middle, that means this median is going to be splitting it 14 on one side and 14 on the other side, because cut 28 in half and you get 14. That I don't think that's too complicated of one there. I think we got that pretty well, guys. So let's go ahead and take a look at what it says in the last one. I like this last explanation, guys, here, or the way they word this question, because it's a good way to see how well we're remembering what to do in this scenario. Let's go ahead and read it, then I'll kind of give a little more explanation there. It says on the last one on C, for this data set, 14 values are smaller, or 80 or smaller, okay? And 14 values are 85 or larger, okay? So the median should be between 80 and 85. So let's just kind of go with what they're saying here. I'm actually going to circle a couple things before I keep talking on this, guys. I'm going to go ahead and do what they're saying. They're saying that 14 values are 80 or smaller. So I went back to that dot plot and let's pull it back up here again. Zoom that in real quick. I circled all the ones that are 80 or smaller. There's 3 here, 6, 9, 10, 11, 12, 13, 14. So there's the 14 that they're talking about that are 80 or smaller. I'm going to go ahead and label that above it. And then they tell us another idea. They tell us on the next part of the sentence that 14 values are 85 or larger. So I'm just going to do the same idea. I'm going to circle the ones that are 85 or larger, and then we'll look at that real quick to see if they're correct in saying that 14 fit that. So there's my 85 or larger. I see 2, 3, 4, 5, 6, 7. Whoops, sorry, I was looking at the wrong pin there, guys. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, here's what they're talking about. There's the 14 and the 14. It says when the median falls between two values in the data set, we use the average of the two middle values. For this example, the two middle values are 80 and 85, and they ask what's the median of the data presented in the dot plot. All right, so pull up that dot plot one last time. They're simply saying that if I pull this dot plot up and I'm trying to find the middle is going to land right in between 80 and 85. The middle's right here. They're asking, well, if the two middle numbers are 80 and 85, how do you get this middle? Well, we know how to do this. They're saying to find the average. And if you have two numbers you need to find the average of, what do? Well, 2 steps. First one, add them up. If I do 80 plus 85, I get 165. And then once you add them up and you want the average of two numbers, how do you finish it off? You divide it by 2. And if I do that, I get 82.5. So to finish off that question, on C, here it is, down here at the bottom, added them to the two numbers that are in the middle up and divided by 2 and got 82.5 as a median. And if we think about that, that sounds about right if I'm looking at this dot plot, simply because 82.5, if I go back up here, should be right in the middle of 80 and 85. So just a nice simple explanation there, guys, about finding the median. So guys, before we jump into the assignment for today, and again, that's all for the notes, just to kind of wrap it up here, when you do the exit takeaways, I'm pulling it up here just a sec so I can read it out to you guys. It should be pretty easy, guys. 2 of them are just asking on 1 and 2, what are the median? And guys, when it says explain your reasoning, that just means show your work. They did you a favor on number 1 and already put it in order from least to greatest, it appears. But they did not do that on number 2. So please, guys, do not on number 2, just circle the number in the middle of that list you're looking at, because you have to put it in order from least to greatest first. So please remember on number 2, least to greatest on that list, then find the middle. Okay? Now keep in mind, guys, on one of these you might get one number in the middle, and on the other one you might get 2 in the middle. So keep in mind, if there's 2 in the middle, you have to add them up and divide by 2. So, guys, also just something that'll help you out here, I think, on this. Let me check something real quick here. Right. So, guys, there should be one example on this, on 1 and 2. One of those has one number in the middle, and one of them has 2 numbers in the middle. So here's my advice. Once you figure out the median, go ahead over on the side and write down how many numbers were in your list. Do that on number 1 and number 2. And then once you do that, think about whether the amount of numbers in the list are even or odd. Like if you had 8 numbers, you had an even amount of numbers. If you had 11 numbers, you had an odd amount of numbers. Think about that idea, and then think about how you might link it to whether there's one number in the middle or 2 numbers in the middle. Because there is a pattern, guys. You're going to find that one of those 2 options, an even amount of numbers in the list or an odd amount of numbers in the list, one of those will guarantee that there's one number in the middle, and one of those options, even or odd, will determine if there's 2 numbers in the middle. So figure that out based on what answers you get for median on 1 and 2. And if you write over to the side how many numbers in the list, that should help you answer number 3. As far as on number 3, simply tell me if there were 35 numbers, would you get 1 number in the middle or 2? And if there are 2, what do you do? And then the same thing on 36. If there's 36 numbers in the list, are you just going to get 1 in the list and that's the median? Or are you going to have 2 in the middle and have to find the average? So that's what you should do on number 3. You're just telling me how many numbers in the middle and what to do if you have 2 numbers in the middle. It'll either be 1 in the middle or 2 on number 3. But keep in mind, you're going to have 2 answers on number 3. One of them is for 35. Have on today's lesson, guys, just a little bit of practice of median and how to view it in the real world. Please let me know, guys, if you have any questions on it, and I will be happy to help you out on that. So good luck on that, guys, and I hope you have a good rest of your day.